But if you have not gone, if you have gone through, it is your risk. Okay, please go through. Maybe
Sir,
thesis
excuse me, sir.
are made in 3 ways. Okay, science we study for application. So applications of adsorption you read. Question will come from there. You go through the applications, and if you don't understand any of the application, you ask me.
Sir,
Yes,
sir, I have one doubt, sir.
yes.
Sir, I didn't understand one statement. It is written that it involves the formation of multi-layer of adsorbent particles. Sir, why
Yes,
do it form multi-layer, sir?
yes. Very good, very good. Say that, as I told you, say someone and you are being dragged. So in that case, you find that his force is more than your force. Then you may call some of your friends. So some of your friend will come and hold you. Then by this way, you will find pull you further. So if the attraction of the adsorbent surface is very strong, then first layer of the adsorbent cannot neutralize the surface tension or the surface force. Then the second layer comes, then the third layer comes. It is called multi-layer. Physical adsorption occur in multi-layers. But in chemical adsorption is always unimolecular layer. Why? Because they form bond. Once they form bond, the place is occupied. Now a second molecule cannot form a bond by piercing the first molecule. Understood now? Because
Yes, sir,
of this
understood, sir.
time, that dust particle hmm, settles more amount on the surface. Why? Because dust particles are settled on the basis of intermolecular forces of attraction. So if the surface area has stronger attraction, then more and more layer of dust particle will settle. And after that, if you put more, when if it is the force is neutralized, if you put more, it will fall down. Understood now?
Yes, sir.
Okay, today we are going to discuss about colloids. See, the particles can be of different size. When you dissolve sugar, millions of sugar molecules are there present inside the crystals of the sugar. So after some time you find the sugar disappears. But the solution is transparent. If you added copper sulfate is blue, pale blue in color. When you dissolve it, the particles are not visible to you. But solution turns blue. Solution turns blue because of the copper ion. So let me draw it. See, these are the water molecules. I have drawn a magnified. Because why you cannot see the particle? We cannot see the particle because it is hidden within the water molecules. It is hidden within the water. So, if the particle size is bigger, then two things can happen. One, if it is very big, then it's visible to you. Just like that, if you put sand in water, sand settles down, is visible to you. If you put some sawdust, then you will find the sawdust is visible to you. But as it is lighter, it floats on water. Okay. So this is the phase which we call it true solution. Here the size of the particle is lesser than 1 nanometer. Right? Lesser than 1 nanometer. Now you can have a particle which is slightly bigger than this. It is slightly bigger than this. That is bigger than 1 nanometer. So human eye cannot visualize it. So if I put it in water, you will not be able to visualize it. But thing is that that particle will not go within the water molecules. So what will happen now here? If this is the water molecule, because water molecules are remaining like this in a clustered form. You'll find as it does not fit, the particle will be here. Particle will be here. Just like that, suppose you are in the old school, you are being surrounded by your friends. You have gone to a new place, nobody knows you. So these are the original friends of that institution. They are together, but you are isolated. So a person can distinguish you that this person is from outside. But in case of these microparticles, it is not visible. But if the particle size is very big, then it will neither go inside the water molecules and it will be visible to you. So here you will find the particle size will fall between 1 nanometer to 1000 nanometer. That is 10 to the power 6 meter to 10 to the power 9 meter. It will be less than 10 to the power 9 meter. And here the size is greater than 1000 nanometer. So if it is true solution, this one will call it colloid. And this one will call it suspension. So the behavior of particles in a liquid solvent we can classify in these three ways. There are three possibilities. Suspension, you have seen, you can make suspension. You can put some sand, you can put some rice granule, you can put some atta. Okay, you'll find it will be like this. Or if you wish, you can put some straw also. Straw will float. In medicine, I think you might have used this medicine in your house. This is antacid. Okay, we call it Digene gel. So in that case, doctor will always tell you that please shake it before taking this one. Why? Because if you keep it for some time, you will find the liquid is above and the particle has settled down. That is a suspension. Okay, this is, I have put sodium chloride or sugar here. But I do not know whether any one of you have made a solution of starch. Have you made any solution of starch in your home? Did you ever use starch solution? Forget about the boys, among the girls. Have you ever seen any starch solution? Reply yes or no. Don't remain quiet. I'll hate this one.
No, sir.
None of you have seen. Among the girls also?
No, sir.
So How do you cook rice in your house? You just take the raw rice and put it in micro oven or pressure cooker and heat
No,
it.
sir. No,
Then what
sir.
do you do?
So we pour water, sir.
Acha. So after the rice is being cooked, suppose if your water is more, then what will do? What will do with this excess water? Do you stir it and make it a soup and drink?
No, sir. We'll throw, sir.
Huh? You'll throw the rice.
No, sir. We'll throw the water.
How will you throw it? Because if you throw the water, then the rice also will fall. So what do you
By
do?
separating.
Huh?
By separating.
How will you separate? You'll filter it.
Yeah, sir.
How will you filter? Tell me, how will you filter it? Any girl, can you suggest him how he's going to filter the rice? Huh? What will do? Hmm? No idea. What will happen? You are not a science student. So this is your pot where you have made the rice. This much rice is there, and this is water. So how will you remove it? Will you make a hole from bottom?
No, sir.
Hole from bottom, what will happen? In that case, you will find mother will cook you. What will do?
Sir, we cover it and then while throwing it, we put a small gap so the water comes out only.
You're a science student. Don't say throw. You will say
The water is drained out.
decant it. Decant. This is called decantation. So if you decant this liquid, that liquid that you get is what? Kitanjali, what do you call in Bengali?
The starch.
Banga starch horse.
I don't know in Bengali.
Acha, Maharaj Kiji gave you. Yes, that is called starch. That is a starch. But is it transparent like this sugar solution or salt solution?
No, sir.
Yes, it is hazy. So this is the one. So why? Because the particle size is bigger and it is not homogeneous. Because solution definition we know. Solution is a homogeneous mixture of two or more substances. So what will be the definition of colloid? Colloid is a heterogeneous mixture. Heterogeneous mixture of two substances, where the size of the particle varies from 1 nanometer to 1000 nanometer or 10 to the power 6 meter to 10 to the power 9 meter. So that is the definition of a colloid. And all of you have seen colloid in your house because we being Indian, we take rice. And when you take rice, when rice is being cooked, you'll find the water which is on the top. It is not as clear as the water that you have added because it has formed colloid. What does it contain? It contains starch in water. So everything depends upon the size, particle size. And don't say we'll throw. We decant it. So the definition of colloid I did not tell you again. Okay. Now, these particles which makes the colloid are called dispersed phase. And the medium or the solvent in which it is being made, this is called dispersion medium. Why do you call it dispersed phase and dispersion medium? Why? What is the meaning of dispersion? You are all English medium student, right? From your nursery level, you had been in English school. What is the meaning of dispersion? Hmm?
To spread.
S-
What is the
Scattering,
meaning of dispersion? Yes, tell me.
scattering,
Huh?
scattering.
Yes, the disease remains scattered. Correct. The disease is present at large. Because of that, we call it dispersed phase. They do not come nearer to each other. And the medium in which they remain dispersed, because of that, we call it dispersion medium. Acha, did I send you this note on surface chemistry?
No, sir.
Okay, you will get it. I told Somnath will send, and then after that you will get. All right. Now we'll go for classification. Classification of. So colloids can be classified into different categories. So first one is the classification based on physical state or phase of dispersed phase and dispersion medium. Please open your book. I don't feel like writing so much. Open the book, go to classification.
So page number.
Why should I say page number? It is your book. My page book not match with you. Mine is older one. Page number, lazy fellow. And book. All of you open the book. Most of you don't talk in the class also. Open. Or that page is not
Yes,
there
sir.
in. Huh? Did you find classification and then did you see one table is being given? Have you seen?
Yes, sir.
Yes, sir.
Yes. Then dispersed phase, dispersion, medium, types of colloids, and example. Even know. You have seen. So one, dispersed phase is solid, dispersion medium is also solid. So what do you call it? Tell me. Huh? Hey, look at the book and tell.
Solid solution.
Solid what? Again read. Is it solid solution written in your book or solid
Solid,
salt?
solid.
Solid salt. So this is the distinction between solution and a colloid. But most of the time for colloids we use the word salt. Examples. Examples given or not? What is the first example?
Colored
Colored
glasses.
glasses.
Colored, have you seen colored glass? Yes, see,
Yes, sir.
those who are Christian, whenever you go to churches, did you not find, you'll find most of the time you'll find in many of the windows in churches, you'll find beautiful designs are being made with colored glass. Have you seen? Hmm? Hello? Hmm? Have you seen? Red is there, yellow is there, black is there, green is there, purple is there. Okay? So it is a colloid. Why? Then what is the dispersed phase? Dispersed phase are the pigments, colored pigments. And what is the dispersion medium? Dispersion medium is glass. Okay? Or what is the next example given?
Gemstones.
Ah. Okay, now, Gitanjali, can you tell me name of some gemstone?
So emerald.
Emerald. How does it look like?
Green color.
Yes. Please remember, most of the gems are made of alumina, a very cheap substance. Alumina, when you put it under high pressure, it is transparent. And this alumina contains the oxides of different transition metals. It contains nickel. In case of emerald, nickel is there. It contains oxides of nickel, chromium, iron, cobalt, all different types of these metal ions or metal oxides are present. And they are being subjected to very high pressure and temperature. By that, they solidify into very hard stones. Okay. And over the years, they have taken to form this type of thing. So, gemstones are colloids. They are all solid sol. Gemstone. Diamond also sometimes contain impurity. So depending on the impurity, see that those colored diamonds are costlier than that of the ordinary diamond. But can you tell me which gem is not a stone? Which gem is not a stone?
Pearl.
Yes, it's pearl. Then solid and liquid. These are simply called sol. Okay. Example you see from there is given there. Paints, cell fluids, then starch in water, ink, mud, muddy water, everything are the examples of this one. Then solid and gas. This is called aerosol. Aerosol. This comes in the form of air pollution. We call it particulate pollutions. Okay. So you'll find smoke, dust, haze, etc. I'm not writing the examples. These are this. 4. Now, see, solid liquid. We have taken here solid liquid gas. Okay. Now we'll go for now again solid liquid phase. So it is, we'll write here now liquid, and it is solid. What is the example here? This we call it gel. Okay. What are the examples given there? Tell me. What are the examples given in your book?
Cheese and jellies.
Cheese, butter, jellies, everything are the examples of, these are all colloids. Then liquid and liquid. This is called emulsion. Okay. Tell me the examples.
Milk, hair, cream, butter.
Yes. Milk is in, let us know. What is milk then? Milk, if you churn, then what you get? If you churn milk, then what do you get?
Butter.
Butter. Butter is what? Butter is a fat. So milk is an emulsion of fat in water. Okay. Butter, does it not melt? See, if you put it in hot rice, what happens? Or hot bread, does it not melt it? Okay. Butter at low temperature is solid, but at little higher temperature it melts. So it is, both of them are liquid. Most of the cream that you are using, most of the face cream that you are using, my dear, these are nothing but emulsion. It depends upon which one that we are going to read later on. I'll tell you. Some cases, this may be, this first phase may be water, and this may be well, or this may be well, or this may be water. So that we are going to study later separately. 6. Liquid and gas. This also you call it aerosol. Aerosol. So what is this? What are the examples given in your book? Fog, mist, clouds, etc. are the examples. Now 7. Gas and solid. We call it solid. So what example is given there in your book? All these examples you have seen in your house also. Don't take much time.
Foam, rubber, and pumice stone.
What is this? Again you tell.
Pumice stone and foam rubber.
Not pumice, it is called pumic stone. Achha, have you seen pumic stone?
Yes, sir.
Where did you see? And what is the use? What is the application of pumic stone? Is
So
it
to
there in
remove dead skins from the feet.
Scrubber, sir, scrubber.
Scrubber? Do you find thousands of holes there in the pumic stone? Is it very
Yes,
smooth?
sir.
The pumice stone that you are using, is it smooth or rough?
Rough.
It is having multiple or millions of holes. In these holes only the gas molecule get trapped. All right. So it is a colloid. All right. All of you are using sofa in your house. Your cushion is made up of foam. Millions and millions of holes are there. Okay. In all these holes, the air or the gas is being trapped. So please remember, foam is also a colloid. Okay. Gas and liquid. When you dissolve gas in liquid, it is not a colloid, it is a solution. So your soft drinks are the solutions. But in this condition, what will have here? What do you call it? Foam or froth. That you are doing it when you wash your clothes with detergents. When you stir it, all the air get now trapped within that liquid and you get foam or froth, or is also known as surf, SURF, surf. I'm not surf. When I say surf, please don't think that I'm talking about the surf detergent. Surf is foam. Now in solution, dear, we also have classified the same way. But in solution, we had 9, where you have written gas and gas. Here it is 8. Why the 9 one is missing? Why they are forming colloids? They are forming colloids because the size of the dispersed species are large enough to be accommodated within the dispersion media. So they do not go inside, they remain side by side. But in gaseous substances, the distances between them is so large, even an elephant also can pass through in between the gas molecules. So there cannot be any question of colloids. It will be always a solution. If you mix two gases, it will always be solution. It will be never form colloid. Please remember. Use little bit of common sense, then you have to read less. All right. Now we go for the second part. Classification based on the nature of interaction between dispersed phase and dispersion media. So before going to chemistry, see, maybe in this year you could not go to school. Last year, little bit time you got to go to the school. So maybe that you are in your old school, or you might have gone to a new school. Say in your classroom you have 50 students. Are you close to all of them?
No, sir.
Huh?
No,
With some
sir.
of them you are very close, And for few, even if the person has not done any harm to you, but you cannot simply stand him. No, nothing he does which you like. You don't like anything of that person. So same thing can happen here. See here, maybe that you went late and you miss, your teacher may force you to sit by a person whom you don't like. Yes, because compulsion is there, is you are sitting. Moment you get a chance, maybe in the next class or next day, you immediately go to your own place. And as because you are sitting in the same bench, you become so close. In that case, if the person has not come, you keep that place vacant because for your liking or affection for that person. Same thing happens with these colloids also. It may happen that dispersed phase have a very strong attraction or interaction with the dispersion medium. Or second, dispersed phase may not have any affection or liking for the dispersion medium. So on that basis, we can classify them into two categories. Okay. First one we call it lyophilic colloids. I'm not going to write the definition. Here the dispersed phase and dispersion medium are strongly attracted to each other and they are highly stable. Suppose due to some reason, if the dispersion medium with the solvent, if it evaporates, what will happen? Dispersed phase will remain in the flask. But to that, if you add water or the solvent, again the colloid is going to form. I don't know whether from your childhood you have used ink, liquid ink. Sometimes we forgot to close the stopper or lid. After coming back, we have found the ink has dried. Then what we used to do is to put some warm water. Shake it, again the ink is there. Same thing happens to the starch also. If starch is dried, put water, stir it, again this colloid is going to form. Because of this, lyophilic colloids are also called reversible colloids. Sometime because you will write that if you read the definition of lyophilic colloids, you go to class for test, your teacher will ask you what is reversible colloids. Gone please. Because you have a habit of reading, you read science and all topics like this. The whole paragraph is written. Who told you only this portion is important? Others are not important. Is that the author is stupid that he will write something extra which is useless? Huh? These are not TV serials, na? So please remember, lyophilic salts are those where there is a close interaction or strong interaction exists between the dispersed phase and dispersion medium. Even if the dispersion medium separates from the dispersed phase, the colloid can be reconstructed or it can be made again by adding dispersion medium. Because of this, lyophilic colloids are also called reversible colloids. I told you the examples. The examples are what? Starch, gum, not a synthetic one. The natural gum that you get it from the nature, from the trees, ink, etc. are the lyophilic colloids. Now we'll go for the second one is called liophobic colloids. Very minimum interaction exists between them in the dispersed phase and dispersion. And because of that, these colloids are not stable. They only find an excuse to separate from each other. Okay, so These type of colloids are called, and once they are separated from each other, you cannot make it again. So because of that, the Liophobic colloids are called irreversible colloids. And to make them stable, always you have to use a stabilizer. Today after my class, you do one thing: in a empty bottle, you take little water. And to that, you add few drops of your cooking oil. Shake it for 15-20 minutes. You'll find it has become blurred. If you put mustard oil, you'll find immediately change of color is there. It becomes blurred. Okay, that is, you have formed an emulsion. Leave it there for today. Next day again you'll find the well is floating on the top because it is not stable. So you have to use a stabilizer. So the cream which is being used, the cream that you use, what you do? We use an emulsifying agent because that also contains well along with the water. How do the emulsifying agent? What is the duty of emulsifying agent? To hold them together. Just like if you want to put a stamp on your envelope, we put a paste. If you want to keep some paper together, we staple it. So emulsifying agent is also like this, they staple it. You know what emulsifying agent they're using it? If I tell you, you will not believe. Detergent, simple detergent they use. Detergent has an ionic part that I'm going to talk here in detail. That part is soluble in water and it has a long hydrocarbon tail that is soluble in the fat or oil that binds them together. Okay. Then third, classification based on types of particles of dispersed. See, what is the condition for a colloid? Condition for a colloid, it should fall between 1 nanometer to 1000. Okay. So it depends upon how it will acquire the size. Say an elephant has given birth to a calf, and a cat also has given birth to a kitten. So are their size same? Calf of an elephant and the kitten of a cat.
No, sir.
Then which is larger?
Elephant.
Elephant. But if you wish to attain the size of elephant by the kittens, then what will? Is not Tom and Jerry cartoon that you'll put a tube in the mouth of the kitten and pump air? It will take the size of elephant. It is possible only in Tom and Jerry cartoon. So how will you acquire it? If you want the size of the kitten should be as big as the size of a elephant cub, that what will do?
Sir, steroids.
Steroids, you cannot do it. We'll put thousands of kitten together. Then their size will be as large as elephant. Is it not?
Yes, sir.
As large as elephant. All right? Because please remember, first of all, colloid is not a compound. Colloid is not a compound. Colloid is a state of a compound. Okay? Sometime you'll find a person, maybe because of this lockdown and anything, you are not able to come out of the house. You are not able to play outdoor game. So in that case, many of you might have put on some weight. Okay? So your weight may increase. But after this, everything is over. Even if you go for playing and doing physical exercise and all these things, again you will find your size will decrease. But you are the same person. So please remember, colloid is not a substance. Colloid is a state of the substance. So when you put on weight, people will say you by the same name, but you will say you become fatty because you have gained weight. When you shed the weight, they are going to call you by the same name. They will not change your name as Motu and Patlu. So colloid is not a compound. It depends upon the anything which falls within this range, it will be a colloid. And it also depends upon the solvent, because it has to fit within the solvent. If the solvents in the whole within the solvent molecules are smaller, even a solute can also behave like a colloid. If I put sodium chloride in water, it is a solution. If I put sodium chloride in benzene, dear, the gap within the benzene molecule is so small, sodium chloride cannot go inside. So sodium chloride in benzene will be a colloid, but sodium chloride in water will be a true solution. Please remember. Okay, so now first we will discuss with those particles whose sizes are very big. Anything which is big, we call it macro. We will call them as macromolecular. This is the size of this individual molecule is very, very large. So which molecule can have a very large size in our chemical compound? These are polymers. So most of the polymers are colloidal in nature. Size is very big. Like in your blood, you are having water and you are having hemoglobin. Hemoglobin is a large molecule. So please remember, blood is not a solution. Blood is a colloid. Starch is made up of here about 2000 glucose molecules. So it's very big size. So when you put starch in water, it forms a colloid. So here polymers can be natural or it can be man-made. Natural polymers are what? Natural polymers are starch, cellulose, then hemoglobin, nucleic acids, protein. Okay, these are all natural. So white of an egg, that colorless fluid that you have inside the egg, that is not a solution. It is a colloid. Where the dispersed phase is protein and dispersion medium is water. Okay. Then you can have synthetic polymer like natural rubber. You can have nylon, terylene, polythene. These are all natural. Okay. Then B. We call them as multi-molecular colloids. See, what is my multimolecular? This type of molecules or atoms are not stable alone. See, if the road is very deserted, if you go alone, you feel little scared. But if 4 or 5 of your friends you go, you do not know when you pass that part. Okay. So in multimolecular colloids, single atom or molecule is not stable. So if the size of the single atom is this, as it is not stable, you will find thousands of such atoms will now cling to each other, and they are not forming bond. For their own existence, they remain like this. Wherever one of them will go, others will follow. Now look at the size. Is it not big? Okay. So these are called multimolecular. Example are the metal salts. Metal salts means what? It may be made from gold, silver, chromium, aluminum. These are all called metal salts. So these are multimolecular colloids. Then the third one. See, here alone they are not stable. In third one, we'll find alone they are stable. The sizes are smaller, but alone they are stable. When their sizes are smaller, you can dissolve them in a solvent to make a true solution. But if you add more, then they form an association or closeness. In that case, they come together and stay together. Like that, if you go to school, when you go alone. When you reach the school, then immediately you'll find you will stay with your few very close friends. So if one goes, others also will go. Tiffin time you'll go, you'll find 5, 6, 7 of them are going together. They are moving together, but individually they are stable. So such type of colloids are called associated. Or sometimes also we call it aggregated, but in your book is written associated colloids. But individually they are electrolyte. They form true solutions. But if you put them more in amount, then they clump together and remain as a in a group. They are called associated. Okay. Example: soaps and detergents. So let me talk to you about this. Any one of you know the name of chemical name of a soap? Suppose the soap that you are using for washing your cloth or taking bath. Do you know what is the chemical substance? Okay. The washing soap contains what? C17H35 COON. We will call it sodium Sodium stearate. Look, this portion is polar. It is water soluble. And this portion is non-polar. It is water insoluble. I told you about your face cream. How does it bind water and well together? This dissolves in water. This dissolves in the well that you have in the cream. So bind them together. So we call this portion to be hydrophilic. That is the light water. And this is, we call it hydro. If you put in small amount, it will go into solution. Okay. Now, if you put them in large amount, what will happen? In this case, you will find so it will be just like this. It will remain together. Now they are inseparable. Now look, it does. Now they are new size. Their aggregated size or associated size is very large. It forms a colloid. This is called micelle. This is called micelle. You require a specific concentration for the formation of micelle. Okay. So this one you call it CMC. Critical micelle concentration. Then only it will form to form a colloid. And you also require a specific temperature. Okay. We call it T. It is called Kraft. This is called Kraft temperature. All right. Now let me talk about something of cleaning of cloth. Say you want to wash your cloth either with the soap or detergent, no problem. Then what is detergent? Okay, let me draw it. The detergent which you use generally, I am going to draw. This is this. This is called linear alkyl benzene sulfonates. LABS. How many alkyl groups are there? Carbon are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we call it sodium dodecyl lauryl sulfate. Don't get scared. We call it sodium dodecyl benzene sulfonate. So this is the detergent, and this is this. Okay. Achha, now you had been wearing your school dresses, whether it is salwar or your shirt. Which portion of your cloth becomes more dirty? I'm not talking about the pants, because pants, so you play and it may fall down and all this thing. Upper portion of the body, the cloth that you wear, which portion get more dirty?
The sleeves.
What? Oh, girls, they don't have collar. But again, you will find shoulder only it gets dirty or not. Hmm? Okay. Those who are wearing t-shirt and all these things will find the collar gets more dirty and slips. She is correct. It means that she washes clothes. All right. Why that portion get more dirty? Why? That is the portion which comes under severe friction with your skin, and it absorbs your body. That well is being secreted by body, it absorbs it. See, if dust falls on this board, if I rub it, will fall down. But if suppose it is little welly here, if the dust falls here, this will not fall, but this portion will fall down. It's not that the dust is reacting with the well or greasy surface. No, because in that case it attracts more. So is attraction is more because of it's not coming. So if I want to clean this portion, what you do, that everyone knows, right? You know right from childhood. You'll immediately rub it with soap. Then you'll find that the greasy layer has been wiped out. You know why, dear? See, grease and well are nothing but organic substances. See, when your hands get, suppose you are doing some work with some cleaning your machine, car, or something like that, and you find a lot of greases in your hand. Normally in your house, what you do, you try to wash this portion with kerosene or petrol. Why kerosene and petrol? Because they are hydrocarbon. So we know I have told you in the solution chapter, like dissolves like. A non-polar substance will dissolve in non-polar substance, and the polar and ionic substance will dissolve in polar substance. So this is the hydrocarbon or very there. See, this is the polar part and this is the non-polar part. See here, in this case, what will happen? All this soap will put their tail inside the. It is so beautiful. So what it is for? It is for myself. Now see, if a thing is heavy, dear, which you cannot lift it with our two hands, we take the help of some other people. When many people put their hand forward, we can lift even a heavier article. This well was sticking to the cloth, which is not removed. All of them has put their hand, and this portion is soluble in water. Any liquid, if suppose you put a liquid water in your bucket, mind it, water is not static. Due to convection current, water moves. And if you warm the water, their movement becomes more and more. So water is pulling them. When water pulls, then the whole thing get lifted and comes in water. If you find that still it is touching there, what do? You do not scrub with brush. When you scrub with the brush, what happens? You generate heat in that place. When you generate heat in that place, the kinetic energy of the micelle increases, and immediately it overcomes the attraction of the cloth and comes out. This is the way we clean our cloth. So this is the whole concept of washing of clothes. Understood now? So what are the precautions you are supposed to do? If you feel that if you put lot of detergent in your bucket and you want to wash your cloth, you think it will be clean? No, it will be wasted. Why? I have already written about the CMC. Critical micelle constant is also sometimes called critical micellization constant. You require a specific amount of detergent to remove dirt from your from your cloth. If you put more, that detergent will not be of any use, because it depends upon what is the concentration of the well in your article which you are going to wash. Second thing we have learned is the craft temperature. That CMC will form, or micelle is going to form only above a certain fixed temperature. If the temperature is low, the micelle is not going to form. You might have seen in your house, many of your mother might not have studied chemistry. They'll tell you if the cloth is more dirty, they'll tell you, please put warm water. Why? Because of this craft temperature. If the water is warm, quickly the micelle is going to form. And the cloth will be clean. So you should not wash your cloth or any other articles with very cold water. All right? Okay. Today up to this much, because next day we start with colloid only, some other topic. Bye then.
Bye, sir.
Okay.
Thank you, sir.
Welcome. Welcome.